Okay, so in the previous page, we show you with some laws which are about this union, intersection, as well as joins. In this page, we can further show some more laws involving the selection operator. And we show you with some examples. Let's assume we have a relation R, and we have two conditions, the C and the C prime, and we want to do the selection of some tuples from the relation R. The condition we have here are the C and the C prime, and we want to do the selection according to the condition we show here. And how can we achieve the result? According to the laws we show in this page, this kind of selection actually equals to what? Equals to the selection of C. C denotes the condition, right? As well as inside we have another selection C prime, and this is on the relation R. You can compare this to each other, right? This denotes the selection according to two conditions. They are connected by and. It will be equals to what? Equals to two selections with this C and C prime separately on the relation R, right? So, they are equal to each other. Furthermore, this one also equals to what? Equals to selection C on the relation R and the intersection with the selection C prime on the relation R. Right? So you can compare them with each other. They are in different formats, however, the result will be the same. And if we plan to prove this kind of laws, you can also use the rules we showed in the previous page, right? If we want to show these two are equal to each other, we just need to show this part is the subset of the right hand side. At the same time, the right hand side is also a subset of the left hand side, right? Similar for this equation here. Besides this, we have another example. If we do the selection C or C prime on the relation R, it will be equal to selection C R as well as the union of the selection C prime on the relation R. You can compare them with each other, right? This denotes an OR between two conditions. It equals to the selection with these two conditions separately and then union them together, right? Another example we have here is the selection C on the relation R joins S. It equals to what? It equals to selection C on the relation R and joins S. Here we have the assumption this C has nothing to do with SS. This C is a condition for the tuples or attributes in the relation R only. If so, then we can just move this S outside of it and we do the selection of the R first and then join the S. Okay, so this is another example. And we have one more example. If we do the selection C, it denotes the condition, right? Inside we have R minus S. This will achieve the tuples in R only, right? Which doesn't exist in S. And this term actually equals to selection of C on the relation R minus S. Here, similarly, we have assumption that C involves only the attributes of relation R. It has nothing to do with S. And furthermore, we can do the apply similar rules to the union as well as the intersection. Selection C of the R union S, it will be equal to selection C on R union the selection C of S. And another one we have the selection R intersection S, it will be equal to selection C on R and then intersection with S. Okay, so these are the laws involving the selection. And you can check the physical meaning of these laws, right? It denotes, the physical meaning should be very clear for you, right? And it will also be very useful for redesign the logical plans or for the relational algebras we showed before, right? For the input queries. And you can check these laws one by one by yourself and also prove it if you are interested in them by yourself after class on your papers. And besides kind of operators, we can also have some laws on more relations. Here we just show you the laws with one or two relations. When we have more relations, how can we deal with it? And we have some examples to show you in the next page.